Welcome back to Masters Live. It's 5 p.m. here in Scottsdale, and the final classes of the day are wrapping up, but the activities aren't stopping.
Tonight we're blending brains with bets, where innovation meets high stakes. Welcome to a night where you can experience the precision of FIRST Robotics and the thrill of casino night. Whether you're here to support the future of engineering or to test your luck at the tables, you've hit the jackpot just by tuning in.
We've seen some of the students' robots being wheeled in, and trust us, these builds are not messing around. You're about to see some serious innovation from some serious talent. Plus, Casino Night is back with blackjack, roulette, prizes, and probably a few friendly debates about probability theory by the bar.
Absolutely. Now joining us now is someone who's helped bring that future to life, Annalisa Regalado, longtime FIRST Robotics mentor and advocate, and a huge part of what's happening here tonight.
Annalisa, welcome to Masters Live. Can you tell us more about yourself, what you do for FIRST Robotics, and what the program's all about?
Yeah, so thanks for having me. Happy to talk about what I do for Microchip. So as the STEM representative for outreach, what I do is help students find a way to get interested in STEM, science, technology, engineering, and math, and then hopefully one day kind of use it as a pipeline to become a Microchip employee or customer.
Very nice. So what sort of skills do the students gain by participating in events like this, and how does Masters amplify that?
So if you walk into the FIRST Robotics room this afternoon, you're going to see 3 different programs represented today. They're all from the FIRST Robotics program. We've got FIRST Lego League, which is our littlest group, our youngest students. It's pre-K through 8th grade. We've got FIRST Tech Challenge teams, which are middle school students, grades 7 through 12. And then we have our FIRST Robotics competition students, grades 9 through 12. And what you're going to see between these different programs is, while they may start out with Legos, they end up being pretty big robots. They're about 150 pounds, play on a basketball-sized court, so you can see just even between the programs the different progressions of the engineering skills. They're going to learn soft skills throughout the program, so they'll learn how to speak to judges, but it's really just kind of looking at the evolution of FIRST Robotics as a whole.
Gotcha.
Nice. And can you tell us more about how this program helps them prepare them for their careers later in life?
Yeah, so some of the students that you'll talk to today advanced to championships this last April. So the students have been in competition January through March, have kind of been dubbed the best of Arizona, and have moved on to compete with over another 1,000 students, 1,000 teams at championships. And the excitement there is just outrageous. Think of the Super Bowl mixed with like the biggest NASCAR event that you could ever have in one building. And there's 50,000 kids running around screaming. But what they're doing is they're taking those skills that they're learning through that robot program and applying it to be engineers. We're having students go through computer science programs. I myself went through the program and ended up, I have a civil engineering degree, not doing civil engineering at Microchip, but Microchip is the only company in the state that has a STEM outreach representative dedicated to something like this.
Nice. Now, for the people watching at home, how can they support or get involved with FIRST?
So we're always looking for support. If they want to mentor a team, again, kindergarten through 12th grade.
Right.
We also have underwater robotics, so if they're interested in something a little bit more advanced. Some of our students go from these programs and advance into our underwater robots. We just wrapped up our last competition for the season in June at ASU Poly, but we're planning our next event for this upcoming June again at ASU Poly. But we're always looking for mentors for those teams, whether it's kindergarten through 12th grade or beyond. We are looking for volunteers at our events, and our events can be as little as 1-day commitments, they can be remote commitments. If you want to have a little bit more time directly teaching those students and mentoring those students, that's a little bit bigger time commitment. Again, we've got events, we're always looking for volunteers, but really just if you would like to get involved in any way, if you have a child that wants to join a team, if you want to volunteer, azfirst.info is our website. It's also where you can find our social media content, see kind of our past competitions, what the students are doing if you can't make it out to see them tonight. But azfirst.info, best place.
Gotcha.
All right. Thank you, Annalisa, for joining us today, and I look forward to seeing the robots in action.
Yeah.
All right, let's head back to Grace now, who's got an up-close look at some of these robots.
Thanks, guys. Hi, everyone. Here we are at FIRST Robotics. Now, there's a lot of robots, and there's a lot of students going around, so let's go check it out. So first we have the potato heads. So they actually are creating robots that help with our oceans and CO2 emissions. How cool is that? Let's keep going. And our second team is the Plasma Robotics. Let's go see what their robot does. Hi, Adeline.
Hi.
So, tell me a little bit about your robot.
Okay, so this is our robot Reckoning, and I love it. So this is for our competition called FRC, or FRC from First Robotics. It's called First Robotics Competition. And my favorite thing about our robot is probably the ground intake. So it kind of gives us an advantage over some of the other teams, because while other teams have to go directly to the source to pick up what we call a coral, we're able to just scoop it right off the ground. So it made our cycle times a lot faster. And the hardest part was probably the coral goes in horizontally, but we need it to become vertical. So that was probably one of the hardest parts, is having to find a way to turn the coral. And it was a ton of fun, just like kind of like innovating and just trying new techniques and figuring stuff out.
Awesome. So what's your favorite part about being in Plasma Robotics?
Okay, my favorite part is probably you can enter the team with like no knowledge whatsoever, and Plasma will just teach you everything you need and want to know. Like, I love what I work on in the robot is I work on a lot of the electrical and like build, and I knew nothing about electrical whatsoever, and I was able to work on it, and I literally learned what each of the wires are, how it connects, all the different devices. So I love Plasma because we got to learn what we want to work on, and I love it. Yeah, we can work on whatever we want to work on.
That's so awesome. Well, thank you for your time. What a cool robot. Let's see. Let's go over here. All right, we have the Saber Cat Robotics, and we have Fiona and Noah. So, Fiona, show me what your robot, or tell me about your robot.
Okay, got it. So this is Ceres, the robot for the 2025 season. So basically, for the game, we need to take those PVC pieces called coral and get them onto the reef. So in our intake, the human player shoots a piece of coral in, it slides into our X-take here. This is our elevator, so this whole subassembly can actually get up to 8 feet tall. We shoot out from there with these wheels, and we've scored a point. And then this whole robot sits on swerve drive, which means that we can turn on a dime. So we're very fast, we're very mobile. And a kind of last minute later iteration on our robot was the addition of this swinging arm back here, you can kind of see. So we need to get those big algae balls off of the reef to score these points effectively. So we decided to add a little batting mechanism in the back.
Awesome. So I heard there was cameras on this thing. Can you tell me a little bit more about that?
Yeah, so from a software perspective, we have 4 cameras on the robot so that we can detect these things called April tags that Fiona has here. We use 2 onboard Orange Pis, which are little computers, in addition to our main processing unit on the computer to detect this and figure out where we are on the field, full field localization, so that when we get to where we want to score, we can just hit a button and it will snap on right where we need to be for the geometry to line up, and we can score perfectly every single time.
Awesome. So what's your guys' favorite thing about being in Sabercats?
I mean, I think the most obvious one is just how creative you get to be. I mean, when kids think of engineering, they kind of think of like difficult math, difficult science, but just being able to be so young, just in high school, and being able to get really creative and try and solve problems in a way that's super interesting, and you have full control. I mean, once you have the challenge and you have something in mind, you can build it.
Yeah, my favorite part is the tools that we get to use. You know, I mean, these robots cost, upwards of $30,000, $40,000. So, I mean, it's not something you'd be able to do on your own. And especially what we need to build these things, we have a huge shop with CNC machines, routers, a ton of computers that can run CAD. And, that's just something you can't really do on your own just as a high schooler. And so it gives us the opportunity to do that and work with industry professionals and gain, like internships and connections that we need to go into what we want to do.
Awesome. Well, thank you for both for your time. Your robot looks great. All right, let's keep going around. Let's see. Oh, we have the RoboHawks. Can you tell me a little bit more about you guys?
Okay, I'm going to direct you over to Evan so you can talk to
Hi.
the students.
What's your name?
Evan.
All right, Evan. Tell me a little bit more about the RoboHawks.
So these were kind of our first iteration of our call design. So we can pick up our game elements, which is kind of like a rectangle prism. So what it does is that it rolls in and it can collect the game elements, and then when we go to the baskets, we put it out. Similarly, over there is one of our past iterations of our crawl. So instead of these kind of these tail stains, we use wheels, so it can better attract those prisms.
That's really cool. So what is your favorite thing about being in RoboHawk?
I think one thing that I like is the teamwork. Without it, it's kind of hard to make a robot process all of our elements together. So we have a diverse interaction with each other.
Awesome. Well, thank you for your time. Happy programming. Let's keep going around. I heard there's a couple robots putting a lot of different things away over here. I'm gonna scoop by. All right. Hi. Hi, Brennan. How are you doing today?
I'm good. How are you?
Pretty good. So, what's your favorite thing about being a Metal Masters?
Probably the best thing is that no matter where you are, if you're experienced or brand new, we're always pushing ourselves to find new ways to improve our robot and to improve efficiency and to be better at everything that we can be.
Awesome. So can you tell me a little bit more about your robot?
Yeah. So this year, you want me to pick it up? Our robot has, the big feature are these coaxial slides. So they're on the same bar that can rotate them and extend them upwards, which was a big thing for us. And we have something called a power takeoff, which can engage higher, like stronger motors to pull up our robot for this year's game.
Cool. And then, can you explain this game to me real quick?
Yeah, so there's two main ways to score. You can score in a bucket or on a bar, and then you can suspend your robot on the metal rungs to get more points at the very end of the game.
Awesome. Well, thank you so much for your time, Brennan. Awesome robot. Let's see what else we can find. All right. Hi, Sarah.
Hi.
How do you like being in Beeper Robotics?
I love it. Honestly, being a part of this team is so amazing because we've been in first for so long. It's just, we have a ton of mentors and members who've aged out that come back and help us. So it's such an amazing experience with all of my friends. And honestly, what's so great about our team, we're smaller, so we have like 5-ish or so people. What's great about it is everyone gets to learn a little bit of everything. So whether it's business, programming, or mechanical, if you have an interest in one of those, you really can like expand your knowledge on any of those topics. So, yeah.
Awesome. So, can you tell me a little bit about your robot here?
Yeah, of course. Yeah. So, we have 2 silicone like molded or poured claws on our robot. So, those are the 2 blue claws. We have 20 3D printed parts on our robot, so that includes some of our Ascent pieces and really just all the pieces that we would make. We made them in Fusion 360 and we printed them in Cura. We really, at the beginning of the season, wanted to make our robot able to do everything on the field, all of the challenges. So as we run our robot, you can see a little bit of how it can hang and place in the basket, and also do the Ascent. So we really wanted it to be diverse and great for competition.
Awesome. Well, thank you so much for your time, Sarah.
Yeah,
These robots look great.
Thank you.
All right. Well, thank you everyone for watching. Here's First Robotics. Back to you guys.
Thanks, Grace. I gotta be honest, that was incredibly impressive and inspiring to see what they've got going on there.
Now, this is the last live stream that we have that we'll be doing this year at Masters. Thank you for joining us, and we'll see you next time. This is Masters Live.